Hey, Dmitro.
Yeah. Hi, Adam. Thanks a lot for having me.
Yeah, it was a fun last time. And today I would start what we stopped actually last time is the ONNX
hmm
or ONNX.
Yeah.
And you managed to read ONNX from Java.
Yeah, kind of because they supply Java bindings for
hmm
it, so it was quite easy to integrate.
hmm
Yeah, I had to tinker a bit with it to understand how to properly use it, but yeah, eventually it actually allows you to really seamlessly embed text from Java. So you don't
hmm
really have to have any external service for that. You
hmm
can use this ONNX, which is basically running inside your JVM process with Java native interface to the ONNX runtime, and it's yeah. You just have an object in Java. You pass a text to it, and you get embedding on the output. So this is
hmm
really nice thing.
Maybe you should start to explain what is ONNX.
Yeah, so ONNX itself is the format, data format to represent the various neural networks, and so usually they are trained in Python ecosystem using frameworks like TensorFlow and PyTorch
hmm
or whatever else. But then when it comes to the inference, then you don't necessarily need to use those. You want to have something, um, no, something versatile.
hmm
Some how to say it? Yeah, some unified, let's say, format which can be
hmm
used to export these models into these formats, and then you can import them into whatever other framework you're using for inference or for fine tuning. So ONNX itself is just a data format, and then there is this ONNX runtime,
hmm
which
The ONNX would be similar to maybe XML
yeah, kind
for
of,
books, right? The XML is not maybe a little bit more structured, but somehow like XML, right?
yeah, kind of.
hmm
And then yeah, you have this ONNX runtime, and they have various bindings for different languages, including Java, starting from Java 8. So yeah, you can just then import this ONNX model. It's just a
hmm
single file. You import it, and then you can.
Into the heap.
Yeah, I think it's imported into the native memory
hmm
because it's not running exactly inside the JVM, but the Java native interface to it. It's actually, as far as I understand, it's written in C++,
hmm
but then you can seamlessly call it from Java. And
So if you,
yeah,
this is a little bit strange, but because it's data format, I would expect just to read it in from Java, but it seems like you are calling C functions from Java, right?
yeah, exactly.
hmm
So data pre-processing happens in Java,
hmm
since you need to kind of transform the input text into, so you need to tokenize it, you need to split it sometimes, and then need to calculate some attention masks. There are some libraries that help with that, but yeah, this happens on the Java side, and then you provide these tensors into the ONNX runtime, which will pass it to the ONNX C++
hmm
runtime.
And remember, so the tensor is a vector with some specific methods, right? It's like a data type.
It's like a multi-dimensional vector, so it
hmm
can be one dimension, can be multiple. It's
hmm
universal.
hmm Interesting. So, and are there competitors for ONNX, or ONNX is the clear winner of everything? You know it?
To be honest, I don't know that deeply.
They have to
So
research because it's interesting
yeah.
whether there is something different. Usually, it always is, right? So,
Yeah, sure. I mean, you can still run these models using Python
Mhm.
libraries, but for as far as Java goes, when I researched it last time, it was summer 2023, and the only obvious choice was ONNX.
Mhm. Okay.
But yeah, would be nice to also have some kind of alternative.
Yeah, for you, not that nice because you have the ONNX, you are done, right? So I mean, you can read down whatever you like.
Yeah, but yeah, I mean, if there is something better, something more
Sure.
efficient, then
So how the Java interface looks, which accesses ONNX? So what are the methods, or how can we imagine what you did? So what is the the Java method to access the ONNX, the low level one? Or how many methods do you have for the GNI, roughly?
So there is one method which is called actually one method is to run the model basically.
Okay.
So you provide all the inputs into it, you run it, and then you get the output. And then
the input is what? Is this a string array or what?
Input is multiple tensors. So one is tokens. So it's text which is converted into tokens, basically numbers. And then there is attention mask and token types. So depending on the model, they require multiple inputs, can be different things. And then, yeah, you just provide it, then it runs internally, calculates embeddings, and then it outputs for each input token. Usually it outputs an embedding, and then we also need to post-process it, so to do pooling, which basically sometimes it's averaging, depending on the model, how the model was trained. Sometimes you have to average those tensors back into single one, or take a specific one, CLS, and yeah. So basically all this logic is wrapped into Langchain4j class, which you don't have to, so you don't have to know about these internal details. The interface then for you is very simple. You provide a string on the input or a list of strings, and then you get the list of embeddings back.
So and this is also part of a LangChain. So the added value is we get the work you mentioned now, the entire conversion back and forth happens inside an adapter class, and it can be seamlessly integrated with nicer Java function method, which is just works with regular Java types, and I don't have to care about the internal stuff.
Exactly. And you can so we have I think 8 prepackaged models which already kind of distributed as a Maven dependency, so you don't really have to know about this model.
Pretty cool. So it means the ONNX format is distributed as Maven dependency itself.
No, they are distributed as ONNX files, and then we take them, we kind of so package them into the Maven dependency, which can be read.
But for me as Java developer, I only have to include the Maven dependency, and it downloads the ONNX model for me.
Yeah, it's inside the jar file, so
this is perfect.
Yeah, but you also have a freedom to take whatever other model you want from Hugging Face, let's say, convert it into ONNX format and import.
Yeah, I know, but for the common things is the right approach, right? I get a battery included approach, so everything is inside. I just can start working, and if I need something special, I can do this.
Yeah.
But I just have maybe nothing else, so this is actually great.
Yeah. For the regular use case, or for the demo, let's say, it's perfect because it's hassle free. You don't have to worry about it. But the quality of these models, for sure, are not the best. So because
which models what do you have, Mistral or something, or what do you?
So sentence transformers models are included out of the box. So all mini-LM v6, it's very L6 v2 is a very known one. Then the one from Microsoft, E5, and a couple of recent ones like BGE and GPE. And I think, I mean, these models, recently they are coming out pretty frequently, newer and better ones. So we'll keep also adding new ones which are better.
Very good.
Yeah.
But the models needs kind of metadata, because you have to know whether you would like to average the tensors or whatever how the integration happens, right? So you have to know it in advance. So how you do it? So you look at the description of the model, say, okay, I need and then integrate them differently, or is it like standard metadata on the model, so you can read it and then adapt different strategies?
Yeah, the metadata itself is inside the ONNX, so the graph of this model. basically, and there is a lot of metadata included on the Hugging Face repositories. So you could go there and take a look, like, for example, if tokenizer, so for each model you have to use a specific tokenizer. For prepackaged, we include them already, so we kind of take care of that.
ONNX package is the tokenizer, right?
Yeah, as well, tokenizer
okay, cool.
as well. Yeah, so you as I said, you don't, as a Java developer, you don't have to know about how what is happening under the hood. So tokenization, data pre-processing, and post-processing happens inside this Maven dependencies, and you don't have to worry about. But if you want to import something specific from Hugging Face, something custom, then all this metadata is present on Hugging Face, so you can go take a look, and it's all documented in the Java doc in Langchain4j. So where to look for what, but three things which you have to supply is the model itself, then the tokenizer file, which is also present on Hugging Face, and then the pooling mode, which is also present there. So
what is the attention mask you mentioned? What is it?
Yeah, it's basically to let the model know where to look at, where the information actually is, because the inputs to the model are usually should be fixed lengths, and the input text can be smaller, shorter, let's say. So you need to also provide this attention mask, which basically tells which tokens are actual tokens and which are just padding.
Okay, so it's just like masking almost in network, right? So you network mask almost. So you say, okay, this is where the content stops, and everything else is nothing, because you always has to provide fixed length as a parameter, right?
Yeah. One more nice. Yeah. Go ahead.
No, I'm curious about the feature.
Yeah, because since we started talking about it, one nice cool feature which we also added is handling longer inputs seamlessly. So these embedding models, they're usually trained for some specific input length, sequence length. Usually it's 512 tokens. And if you have longer text, then usually what you have to do is either split it manually and then embed separately, and then try to kind of match that back together. Or common strategies are just take the first 512 tokens or the last ones. But what we do under the hood is also, if the input is longer than that, we also automatically split it into the smaller chunks, embed them separately, and then do the averaging using weighted averaging. So basically, this is not really recommended for most use cases. For retrieval, let's say, you better split it into smaller chunks, which fit perfectly into the model. But if you want to, you have a whole document and you just want to embed it completely, you can just pass it in, and we will also take care of that. So this is pretty neat stuff.
So you are almost concatenating the input, right?
So the input is split into multiple batches, and then each batch is embedded separately. And then we have multiple embeddings, so we just average them, but using weighted average depending on how many inputs there are. So to basically the idea is to give you back one single embedding which represents the whole text.
Are you speaking about the input or output? Input, right?
So can you say again?
Yeah. Are you talking now about the input or the output? Input, right?
Yeah, the input is split.
Yeah, exactly. So, and what I understood is, I provide you, a longer prompt, and because of the limitation of 512 bytes, you have to split it, average it. But for me, I have the convenience to provide you a longer prompt, and you are splitting. And if you split this, my understanding is now what you said is that you have to average it for mathematical reasons, and then then you submit, I guess, multiple batches, right, of 512. So if I give you 2048, so you will send 512 batches with averages, right? Averaged 512 batches?
Not really like that. So if you provide 1000, then it will be split into 2 batches. Then it will be the model will be called twice on each batch.
Exactly.
And then on each output, you have embedding. So you will end up with 2 embeddings. But what we do?
Okay. So do you have double problem, right? So there's the input problem, and of course, but because the model is stateless. So if you pass 512 in, you get something out, maybe also 512, and you have concatenate on the output and split on the input, right?
Yes, exactly. Kind of like that, yeah.
Yeah. So and you have to what you said is perform the averages on the input, and then also averaging the tensors maybe on the output, and depends on the model, you said, right?
Yeah, averaging happens only on the outputs. So when you have 2 embeddings, then you average them together. So 2 embeddings are basically 2 arrays of floating point numbers. And then when you average them, you take basically the average of first 2 first index, average of second index, and so on and so forth. But if you have if your text is not split into equal size lengths, like in the example of 1000, then it's kind of equal input and output. Sorry, not 2 equal batches. But if you fit something like 600, which will basically first do 512 and then the rest, then you need to apply the weighted averaging. So because on the output, first vector will represent like the first 500 tokens, and then the second one only 100 tokens. So they are not really equal. So you cannot just take them and average them 1-to-1. So you need to do weighting.
But you can do it automatically. If you see it is the same length, you have one strategy, and otherwise the other one.
Yeah. So it's all under the hood. You don't have to worry about it.
Still cool. But the input is short as the output, right? It is not 1-to-1 length. My input prompt can be longer, shorter is usually than the output.
It can be shorter or longer.
Exactly. There's no 1-to-1 relation of the length, right? So it doesn't. Exactly.
Yeah, the embedding which you get back is always the fixed size.
Okay.
So it can be like for the smaller models, it's usually 384 the length of embedding, but it can range depending on the model. The bigger the model, usually the bigger is the length.
It's almost like a pointer, right? In memory somewhere. Yeah. The bigger the memory space, the more you have to address. Yeah, is it the length of the embedding has to be somehow related to the number of parameters, right, of the model?
Not necessarily, but yes. I mean, usually there are new modern techniques which I think it's called matryoshka embedding, where the model is trained to output embedding, and then you can just cut off some numbers from the back, and you will not lose much in quality.
Almost like a git hash, right? Commit hash.
Probably, yeah. So the idea is that the model learns to put the most important information in the first into first dimensions, and then slowly going to the end.
This is smart, because in Git only means it is usually unique enough. So if you pick the first node 10, you will win to find a commit. Yeah, and this is different. This is like the information is encoded, the relevant information is encoded in the front and then decreases, right?
Yeah, so you can also do it, this kind of trade-off, how much data you want to keep, because if you have lots of textual information you want to embed it, then you will have a lot of data. So if the storage is a problem for you, you can then basically just cut it, and then you decide on this trade-off, quality versus how much storage you need.
Okay, cool. So input is the split and not averaged, they say. Input is not averaged, on output is averaged, right?
Yeah, right.
So, and input is just split and nothing else, right? So you're just sending the input, and you have an index somehow indexed because you have to remember input in output, so you have to match between both internally, right? And then you get it back, and then you have concatenate or by averaging the output. And then we have the embedding as output, which is a long number.
It's an array of numbers, yes. And then you can use it for whatever different purposes. So usually for retrieval, so you can store them as these embeddings into the vector stores along with the text which was embedded. And then you can search when the user query comes, the user asks for something specific. Then we can also embed the query, have the same embedding. I mean, not the same, but I mean the same representation. Then go to this vector store and search by this embedding and try to find the similar ones.
Okay. So, but if we just say have something like Llama, so ChatGPT similar functionality. So I just would like to ask, whatever, is Java great? So this is split in 512 bytes, and what I get back is embedding, but the embedding has to be mapped to the text or resolved with the text, right?
Yeah.
How you do this? So I mean, you need somewhere a more, how to call it, generic vector database, because you have to resolve the embedding with a text, and you don't have the text, right? Because it's not rect. This is just generic question to a model, and you get the embeddings back, and you need the text behind the embeddings, right?
Yeah, for that you have another type of model. So what we just discussed is a specific type of language model.
Okay, what to discuss now? Because
it's called embedding model.
Okay.
Which the sole task of it is to convert text into this embeddings representation.
Okay.
So this is not a regular language model like ChatGPT, what we usually used to.
Okay, for embeddings makes absolute sense, but it's okay. But if the text is generic, I have to know another type of a database to resolve it. But okay, go ahead. And if it were Olama, something like this, like GPT-like experience, local.
Yeah, then you have another type of model, which is language model, which is text in, text out. But when you have text in, then you can additionally to what user is asking, you could also supply additional information like from embedding store, which was rect, and then the model will be grounded, so it will answer using this factual information, and the risk of hallucinations will be decreased a lot.
But it's we will talk about rec in a moment, I hope.
Yeah.
But what the just generic, offline is interesting. ChatGPT is a bit boring. It's you have something in ONNX. Is something similar to ChatGPT in the Maven repository already?
Not really, but in the Docker repository. So on the Docker Hub, we have multiple Docker images ready to use.
Llama or Mistral are very similar, right?
Yeah, so it's basically it takes the Olama Docker image and pre-downloads the models, the most popular ones like Llama 2, Mistral, yeah, what you mentioned, Phi, Code Llama, and so on. And then you can.
What is Phi? I don't know Phi.
Phi or Phi, I don't know how to pronounce it. Right, so this one was a very tiny model from Microsoft, which still is quite impressive if you take a look at the number of parameters it has.
And you don't push it to Maven because it's too large. So this is the reason, or?
Yeah, of course. They're all north of 1 gigabyte and larger. So your language models are much bigger.
But what we could do, right, with 1 gigabyte to have a more integrated experience, we can push it to enterprise repository somewhere, not to the Maven Central. So there could be a script which now reads from the Docker, push to my own Maven, and then I have an Dockerless experience, right? This could work.
Yeah, of course, but then you need some inference runtime also figure out, because right now it's all handled by Olama, which is a very nice API, I would say. I mean, they have also UI thingy, but basically you can just download whatever popular model is out there with a single command and just run it magically. So you don't have to worry about how to do that. And in Java, if you want to use ONNX with it, I don't know. I didn't yet even looked into that.
It could be interesting, right? So this is there's I saw on GitHub someone did it with the vector API in Java, and they integrated, I think, with Llama directly. And this is just one Java class, Java 21 class, which is crazy. So
yeah, that was cool. I think it's JLlama or code like that. Yeah, I also saw that. It's pretty
so
cool.
this is missing, yeah. So if you have time or someone would like to contribute, right?
Yeah, that would be awesome.
But in that particular case, I would send a string. I think the string has to be still split, right? Or no more in this particular
it should be tokenized.
Still, I get back a string, right?
Yes, you will get back a string, right?
Okay. Okay, cool. So no, wait a second. I think what we get back are batches of strings, because this is why it looks like a stream in ChatGPT, right? So if I go to ChatGPT and ask a question, it looks like, I'm getting per WebSockets the text delivered piece by piece.
Yeah.
And I think this piece by piece delivery is the batching, right? What I get out. So I get, the first batch, second, and what they are doing, they are streaming the chunks to the UI, I guess, right?
Yeah, they're streaming token by token. So the model,
exactly.
When it takes the input and it starts the generating process, it generates a single token on each step. Basically, text in, and then it generates predicts the next token. And then this token is streamed, and then you append this token generated to the input, and again give it to the model, and it generates another one. So once these tokens become available, you could stream them. But
so what they are doing in ChatGPT, they have model behind the scenes, but the entire output is fed in again into the inputs, right?
Yeah.
So that because the model is stateless, and you have, the model has to know. This is usually what should happen. The longer the prompt, and the longer the output, the longer the processing should take, right?
Yeah, exactly.
This is now interesting.
And then so streaming is also supported. So we have different type of interface for streaming, where you could register a callback listener basically, and whenever a new token is available, then it will be called and you can handle this token.
This is not the concatenation what you did in output, so this would be alternative, that you get immediately notified that the new embedding is there, right?
Yeah, exactly, but not embedding text. So those two are two different things. So embedding model is there is no streaming there. You just
it's too fast, right? Because the Matryoshka could make sense, right? You get the first one, which is most relevant, and then less, right? So I could actually.
I'm not 100% sure, but I think that embedding is generated simultaneously. So you will get back all the numbers at once, but yeah, then you can cut it if you want.
Makes sense. They are smaller. And I guess they're also faster, right?
Yeah, they are much faster. They are much smaller usually. So they are much faster.
Yeah, pretty cool. So we covered the embedding models, a little bit of the text models, which you said, is not completely integrated now. How to call it? Pure Java integration is not done yet, but they are integrated via Docker. So this is with Ollama. This is what I understood.
Ollama and local AI, and there are actually lots of different inference APIs already available, so you can use many of them.
Many inference APIs. You mean in Langchain or by models?
I mean things like Ollama, local AI. So those ones are kind of, they host the API, which is usually similar to OpenAI API. Which handles, so you send text as input, some
but
parameters.
via network, right?
Yeah, via network.
Okay, this of course,
REST.
yeah.
And then they call the model behind the scenes using various inference backends. So you can also run it also theoretically in ONNX this way, and then you get back the text generated.
Yeah, the remote is more fun because there's nothing to do, but this is less valuable for companies, right? Because in Europe, no one is really likes to call something else, right? And
Yeah.
if you can run it locally, you are
But you can.
independent,
But
right?
you can run it locally. So all those inference servers, they I mean many of them they can be run locally.
Mhm.
So they're open source. You just download the server, download the model, and
Yeah,
just run it. And you can host it internally in the company and
yeah.
just call it via API.
Okay, so the model would be that the inference server is independent from the Langchain machine. So the Langchain machine will be the front end and call per REST and local server, right?
Yes, yes, exactly.
And does it make any sense, to integrate it via ONNX directly? So you say, okay, I don't need the server. If I have power, I can just directly call it. Or usually they are server clusters, what you're talking about.
Yeah, I mean, usually to get a nice performance, you would need a GPU. And
Okay.
so for that, you will need a specific kind of hardware, right? So it's not.
Yeah, it depends because Olama is good enough without any GPU support, right? I mean, this is.
Yeah, you can run it on CPU as well.
It really depends. I would say if you really need, the power of GPT-4, forget it. Use GPT-4, right? But if with some tricks, which you already mentioned, maybe something like Olama is good enough. For instance, something like to implement, a state machine or a small rule engine, whatever. I would say the power of Olama should be sufficient, right?
Yeah,
If you yeah,
yeah. I mean,
or parsing, if you have unstructured data and you will to parse something and you have the tests, I mean, a smaller model, more specific one can have more advantages than a godlike model like GPT-4, which can do everything. But I think the trend should be in longer term to more specific models. For me, it doesn't make any sense to train a model with billions of parameters, make it smarter and smarter, and you need only know to understand CSVs or to integrate to servers or whatever, right? So I would say for enterprise context, I think there will be an age of small, very specific models, and then the hope would be maybe even pure Java models like the deep nets or whatever, right? So that we have no integration pain points.
yeah, I totally agree. So I also think the trend will go this direction. And yeah, but what usually happens is usually to start fast and easy, you start with GPT
Yeah,
4,
exactly.
let's say.
Hmm.
Then you collect fine-tuning training set
Hmm.
using whatever means, and then you can fine-tune a smaller model. It's much cheaper to run. You can run it even on CPU as you mentioned. So
Exactly.
yeah,
Because the entire, if we have the assistant, the assistant prompt means already I would like to have something specific, right? It's like you are this and this, and this you are this and this is the same as you are the model, right?
yeah,
If we are just a model which is just SQL model, then we don't need the entire GPT baggage. We only have the SQL model to create SQL from text, right? So this is the only thing I need. And if I ask, what's the weather tomorrow, then no idea, right? So I answer
mhm,
this will even from the security perspective better because why my SQL generator has to know about weather or not weather is a very bad example, but generate images, let's say, right? Yeah.
yeah. And you can with this approach, you could also have multiple specific smaller models handling
Hmm.
different tasks. So when the
Exactly.
request from the user comes, and you can classify it. What is it
Exactly.
about? Is it about, I don't know, Java or weather? And you can route
Yeah.
it
Exactly.
to different more specific models.
And
Um,
even the weather model, what it can just do, right? The weather model could be also a very good one because it could call the tools,
yeah,
to get the actual weather and just write, nice article around that and provide some images, right? So I mean, this will be perfect job for the model because the facts are there and you can ensure even test, right? You can write a unit test for it
yeah,
because you can say, okay, model, we have 1,000 unit tests. The input is weather Munich, 19 degrees and this should be inside the output. If it is not, it is wrong. But if the picture is wrong, it's not as bad because the data is also embedded.
yeah, exactly. It's also I think it's nice way.
Enrichment, right?
Yeah, I think it's also nice ways to think about it. Yeah, instead of having just one single interface, which with a complex task which can handle whatever
Yeah,
user asks, you decompose it, deconstruct into smaller subtasks, and then you can handle each one much more easily. You could unit test it. You can fine tune this step.
You see already in my work. So actually, today for the podcast, I say, okay, create a summary for the transcription, and then I say I need a more technical title, and just the more technical title change the entire behavior.
Mm-hmm.
So this was like a one maybe half page prompt, and one small word said, okay, title more technical, had impact on everything outside. So I said, okay, then now I have to split it, right? So it's the first thing. So okay, then I will, maybe it is too much for the model, so I will have 3-4 prompts and then aggregate the data afterwards.
Yeah.
But this also changing everything, because then I have I would like to have not the text bags rather than JSON, and then aggregate the JSON, extract the data, and maybe put it the last time to the model and say make it nicer or whatever. So I think this is the future, and the Langchain can be something like AI application, right? So this is the AI app, which can use different models, and the models are almost like a microservices, or small, and
exactly.
can aggregate the data inside and provide a boring interface to it, like JAX-RS in my world with Quarkus, and we have perfect enterprise application.
Yeah. One thing which we think makes sense here in this context is this idea of AI service, where you can represent communication exchange with the model into one simple interface. And when you have this complex task, and you can decompose it to smaller subtasks, as you mentioned, then you create a separate AI services for each of those, and then you can manage them much more easily. So this works pretty nice.
And this is like almost like refactoring. So I'm pretty sure we get to know the first talks at conferences about prompt refactoring and AI model for refactoring, because people will notice that one model is a little bit problematic. So we have more of them, and how to coordinate between them.
Yeah.
And interesting times. So now we mentioned already this RAG. This is Retrieve Augmented Generator. Or what?
Yeah.
Generation. Okay, I cannot remember this.
Yeah,
And now let's do, what would be the classic example of RAG? Like FAQ or what?
Probably, yeah.
Then maybe we do FAQ with the data is in Postgres table. This is a realistic one, right? You could do.
Yeah, you could do that as well. So you could also retrieve data from Postgres.
Yeah, because most of CMS have the data in Postgres, or so this is why. Or we can do with text, is like, but Postgres, who cares, right?
Yeah, the data source itself is not really relevant. So you could fit data from whatever source you want.
Yes.
Out of the box, what we support is the best support is for embedding stores, where you have data and embeddings.
But what I thought is I will have to create the embeddings from the Postgres first.
From the text, yeah, it can
from the text in the Postgres. So I will scan the table first. I will select all from table and give you all the data, create the embeddings, and then you will the job of the AI would be very simple one. If you have the embeddings, find out the primary key from the table, right? This would be the association. Because what we need is, at the end of the day, the actual article in the table.
Yes.
And the table in the table is uniquely identified by the primary key, right? This would be.
Yes, exactly. You can do this way as well. So you could also associate embedding with this primary ID.
Exactly.
And in embedding store, you could store only embeddings and IDs. And then you could map it to the Postgres.
But this could be a good idea, right? This would be, for most enterprises, they have huge databases, and they say, okay, I would like to be strictly hallucination free, or at least detect hallucinations. So we scan the entire table. We create for the entire table embeddings first, right? This would be an independent batch job, which runs on every change of the table, let's say, or nightly or whatever. So we get then, okay, so how we could use Langchain for it. There's no problem, right?
Yes, you could.
So this would be a Langchain sync application, let's say. This would be the first one, right?
Because this is what we call data ingestion pipeline.
Data ingestion pipeline.
Yeah, it's so you have an embedding store, embedding model, and then some data source, and then you can run it and import the data from data source, embed it, and store into embedding store. And it can be either, as you mentioned, you just store embedding associated with ID, or it could be embedding associated with the content itself. So if it's not
I think in enterprise would be ID better, because this is like the reference. You click at the reference, and this is the proof. So I think copy is wrong because no one will trust that. So okay, is this really the copy? Maybe this is different. So I think a reference is a good idea. Either ID to a table or REST interface, it doesn't matter, right? So URI or ID. But the table is maybe interesting. It's an unusual one, and everyone has a table, right? In the enterprise.
Yeah.
So we have the ingestion pipeline. So we will create the embedding database first, right?
Yeah.
Which one would we suggest for this purpose?
To start with, I would suggest to use just in memory one. So it's very simple to start. I mean, it depends on.
But what is the name of the store in Langchain? Which one?
It's called in-memory embedding store.
Okay, in-memory embedding store.
Yeah, it's basically just a collection of embeddings, and it's.
Is your store or is it the external store?
Yeah, it's our store.
Cool.
So it has all the same features and even more than the rest. It's nice. I mean, it's tiny, it's lightweight, it's nice for demo, for prototyping. You can also persist it to disk if you want, and then recreate back. So this way you don't really have to, spend a lot of time trying to figure out which embedding store to use, because there are so many of them. Currently we have more than 15 integrations, and probably more and more will be added. So yeah, I would suggest to start with this one, and then look into your use case and go from there. Try to see what exactly you need.
Okay, so in the table we have stored all Langchain extensions or plugins. So this would be, and the question would be, what is the best plugin to complete to perform my task for this and this? And the expectation is I get suggestion from Langchain, what is the best for Langchain, right? So this question I ask you, what is the best, embedding store for this task? And let's implement this. So I would say in the table, we would have the list of Maven dependencies and plugins, right? This would be the ID is the ID, and this is the plugins are plugins with some additional information, of course, what they are doing. Because there's no, it would be like what you said, the in-memory embedding, lightweight for test, can be persisted, but has probably problems with size. If you go you hit the hip limit, then you are done. So you need the other one, and the other one have other features, and this is what we can search for, and we can have in the table everything. So whatever we mentioned, from all the models, the embedding models or whatever, so it will be like generic Langchain store. Okay, so I now asking you this, so you will have to create from my question embeddings as well, right? So this ingestion we already covered. We read, the database with Langchain extensions, create the embeddings, and now the step 2. The step 2 is called inference, right?
Step 2 is called retrieval. So once you have the question from the user, now you need to retrieve relevant information from your embedding store. And what you do is you take the question from the user. You could either use it as is, or you could process it as well. So you could expand it or summarize it or generate hypothetical document embeddings. So there are multiple strategies how you can.
Okay, how to do it with Langchain? How can expand it or embed it?
Yeah, so there is this advanced track package in Langchain, which has interfaces like query transformer, and then query transformer is just the component which takes in the query and transforming it somehow. We have multiple out-of-the-box implementations like summarization and expansion. So, for example, if there is a long conversation, back and forth questions, and then user asks some follow-up question, which doesn't necessarily contain all the relevant, details about what was talked before. Then you might want to summarize the whole conversation into the one single nice query, which would the query will contain all the needed details for retrieval. And then once you embed it, then you go to the embedding store and retrieve all the relevant information which is similar to this query. And this can be also done, so you are not necessarily having to...
So first you pre-process the query with expanding on summarizing. What I understood, the summarizing is if the query gets too long because it was like follow-up, right, query? This is what I understood. This is the only reason, right, to do it.
Yeah, but just as example, in first interaction with LLM, you ask about, I don't know, some specific person, and it gives you an answer, and then you ask it, how old is he? So if you embed how old is he, it doesn't really contain all the necessary details about who is he. The model doesn't know who is he. So if you summarize it, then the summarized query would look like how old is and then the name of the person.
Okay, but then I will also have to have access to the chat memory first, right? Retrieve the entire conversation for chat memory, then pass it to the summarizer, and then this is always a good idea to summarize, right? Because
I mean, it has its pros and cons. So the process, yes, it improves a lot. The con is that you have a much higher latency, because on each interaction, first you need to go to the language model, summarize it, only then retrieve and proceed. So it might take a couple of seconds of latency to the whole process. And once your query is transformed, then the second question is you're asking yourself is where to use this query, where to route it, to which data store. So you might have a single embedding store, let's say, in a very easy scenario, but you might have a multiple data source. Like you might want to also use internet, Google search, let's say, or you have another one in Postgres or in some other SQL store. And there, this query routing idea comes into play. So given the query, route it to the appropriate one or multiple appropriate data sources. And this can be done either, again, using language model. So you say, okay, here's a query from the user, and I have the following data sources. Tell me which ones are the most appropriate, and it will give you.
But who will give you? So I need another model like multiplex.
Yeah, language model.
Yeah,
it can be some specialized fine-tuned language model which would detect like what is the best one data source to take.
But in case of GPT, we could use the tools and dynamic function stuff to do. Maybe tools better, right? So we could register upfront with OpenAPI all models all external resources we would like to talk to, and then the ChatGPT would decide, okay, it's time to call, I don't know, this or this, right? GitHub.
This is another way how to do that. So
okay, how you would like suggest then? So what do you think?
So in retrieval augmented generation, this step usually is happening automatically and is forced. So on every interaction, you ask the model where to route this query, and it will pick the right data source, and then we go to this data source and then retrieve.
Then the rec pattern enforces that the model can select, the functions, right?
Yeah.
Okay.
And models on each step of this rec pipeline, model can be different models. So you don't necessarily use the same one. It's not like they all share the same memory. It usually happens like they are completely stateless. So the summarization expansion step is handled by one model, fine-tuned for this task, and then routing is handled by another one. And then once you have a list of a set of data sources, and you go and retrieve from there, from, let's say, some content comes from embedding store, some content might come from Google. And then another step before finally passing all this information to the final model, which will reason on it and answer the question, you want to also aggregate this information. So since it comes from different sources, it's ranked differently. It might not necessarily contain really relevant information. It might be complete garbage. So on this step, you want to aggregate it, and usually what is done is re-ranking. At this stage, you again provide the query and the list of retrieved documents to the specialized model, re-ranking model, which was trained to decide which content is actually relevant and which is not, and it will re-rank, so it will sort the input documents from the most relevant to the least relevant, and then it will give you also the scores. So you could also decide, okay, the first and second content which was retrieved is really relevant. I want to take it and give it to the model, and the rest I just drop, because it's all eats up tokens and latency, right?
A question, because a specific advice. If I use Langchain4j, so for the first part, decision which model to pick, what you would suggest, which model should do this? You know what I mean? The decision, which data source to pick. Sorry. So we have, the we have the question, and then the question is, who can answer the best, or which data source to consult, and or maybe all data sources. Which model you will use for that?
I mean, most of the things which we develop, we try to make it work out of the box for multiple models. So by default, we keep in mind GPT 3.5.
Okay.
It's quite nice. It's fast and it's very cheap. So if the functionality works with it, the chances are good that Llama 2 and Mistral will handle it well as well.
So the first choice is GPT 3.5 because of the turbo or no turbo?
Yeah, turbo. It's very cheap, and everyone can have access to it.
So then you can using this model for the tools section. So data source.
Yeah, you could detect that. But again, this step is all what we discussed now is optional. So each step, like query transformation, it's optional. You can just use query as is. So
exactly. Just do the extension part. So this was now the enterprise solution, and now just for our case, we pick the query as is, and we get embedding back, right?
Yeah.
And then we have to associate the embedding with the primary key in the database.
Yeah. And it's all done inside the embedding store. So it will keep the embeddings. It's like a map. You can consider it as a map from embedding to the ID. And then when you give embedding of the query on the input, you get on the output a list of IDs which have embeddings which are the most similar to the input one.
But in one point of time, I have to search in the embedding store for the SQL key, right? For the primary key.
Yeah, it's exactly what is happening. So for search, you give it the embedding on the input, and it tries to find all the embeddings which are very similar to this one in space, so the most similar. And then for each of those, it will retrieve the ID.
You also implemented the search in the in-memory data store.
Yeah, I mean, it's so this is pretty trivial exercise. So what you do is in memory, usually you would just go and brute force through all the embeddings. You calculate the similarity with each embedding.
This is Knabe, or what is it?
Yeah, it's Canon. So this is another advantage of using it for the demo, is that you will always get back everything that is really similar, and not like for ANN there is a risk that some information will be lost.
And you get array of IDs done back, right?
Yeah, you can think about it like that. So you get back the array of embeddings and with associated metadata, and then you can retrieve whatever you want from that metadata.
Okay, so this would be somehow easy exercise to have. But now the interesting part, there are no hallucination. The only thing which can happen is that the question doesn't match the answer, right? This is the only danger we have. So if something goes wrong, and the AI thinks, the query is about Docker on shipping container, and not the actual Docker, we get no how to call it, no answer found, because in your database is nothing about shipping containers, just Dockers maybe. So this can happen, but because we are embedding a reference to your own database and you get it as is, so there's no hallucination. So we are using the AI as a matching engine, more or less, right? So we give a question and we get set of answers, maybe a little bit, enriched and summarized, but there are still, we can always add, the references where the data comes from. This is the added value.
Yeah, this is really nice because you can actually ask the model to also cite each statement that the model gives you back, like each fact or statement, to also supply the reference where it came from which input document which you fed to it, so it should reference, and then you can even cross-reference. You can automatically check whether it's actually true or not, or LLM hallucinated this step. So it might also attribute some fact to something. I mean, really unexistent, right?
You could even cross-check, right? What you could actually do is you can use another model, pass the answer with the citations, and then the links, the actual content behind the links, behind the IDs, and ask another model, do they have something to do with each other? Or not even another model, we could create two embeddings and check, the similarity of both, right? So this will be the cross-check. So this will be the unit test for the model, right?
Kind of, yeah. Yeah, it's a very widely used approach, very simple one, but very powerful. So yeah, you just send back to the model the answer it just gave you and the question again, and ask it to double check. Let's say.
But maybe different model, because or maybe we don't need a model at all. We need the embeddings model, right? Because I think the better check would be to create an embedding from the answer and embedding from the resource and see how similar they are.
Can be done like that, yeah, but I think the quality of that will, embeddings are still quite limited.
Okay.
So I would suggest using language model for that. For cross check, can be the same model, can be different model. So it's
for cross check always different, right? I mean, for cross check it should be different, right? If you don't trust a model from enterprise, in enterprise space, it should be different. Because otherwise you will argue, with everyone. Yeah, but what if the model is manipulated? It's like, yes, then you have, to explain over and over again. And if you pick different model, there is no questions left, right?
Surprisingly, even using the same model for cross-check works really great. So that's
but
really
but
interesting
from
part.
technical perspective, yes. From human perspective, if you say we're creating with this model and another model checks, we have better feeling, right?
Yeah, of course.
It is just about feelings.
Yeah,
a little bit marketing.
In the future, for sure, there will be specialized models which will specialize only on this, on cross-checking, and making sure it works. There is no hallucination. So
okay, the simple case and the highly sophisticated case was we not only have the SQL database, we also have Google search and ChatGPT as data source. It could be as well. So we use ChatGPT as data source. We ask the question and get ChatGPT straight answer. It could also be used as a data source, right?
In theory, yes.
Nothing. We have just an abstraction with an URI. What is behind? I don't care. So we have Google and let's say ChatGPT 4, and then then we need a ChatGPT 4 or GPT 3.5 Turbo. And what we do, we pass the data sources with the prompt, and we'll decide, which data source to use, or use all of them. Could also be, right? Because if you will use all of them, then the next stage is the ranking, what you talk about, right? Then it has to be somehow ranked and quality assured.
And to route it to multiple data sources, you could even use embedding models for that. So this is good use point for that.
To routing to the data source, because the data sources ship with metadata, which can be an embedding itself, right? This is what I mean?
You can basically embed all the information about data source some examples of queries which should be routed to the concrete database data source. And then when the query comes, you embed it, and then you basically do a reg over over the data sources. So you are trying to find the most similar ones. And this is very nice because this process can be done completely offline, very fast. So there is no latency. You could use this in-process ONNX models for embedding, and then you save a lot on time, right? So you could route it very cheaply. This is a very, very nice thing, and you can already do that out of the box in Langchain4j.
Cool.
So you could classify, let's say, that, for example, the topic or the intent of the user. Let's say you have a chatbot, which a customer support agent of some store. So depending on the user query, whether it's a question about some product, or maybe it's a complaint, or maybe just some suggestion, you could classify the intent and the sentiment of the user query using these embeddings. Very cheaply and very fast, and then automatically route it. I mean, not automatically, but route it based on this decision.
Yeah, but creating the embeddings for the data source, what I will do is I will ask the data source, get the answer, then provide my own metadata, but then even add a sample, the question and answer, then create embedding from the entire text. And this would be a pretty good explanation of the metadata, right?
Yeah, I mean, the possibilities are endless here.
Yeah, sure, but no, just as a starting idea how to do that. Because because if there's examples, work usually well. So if you provide, if you ask this model this, you get as an example this answer, and then add some classification what it is. So as you said, customer support, whatever this is, and this is the example, and then you pass the text to the embedding data store. And you get the the embedding model. You get the embedding array, how to call it, the embedding spec, and then you store the embeddings, and on as value is the reference to the data source, whatever it is, right?
I'm not sure I fully got this idea, but how I like to think about it is that when you have multiple data sources, let's say about different topics. So you could associate, let's say two embedding store. One will contain factual information about animals, and another one about, I don't know, technology. Then what you can do is you could just generate synthetically a couple of example questions which each data store could answer. And then you could embed these examples and keep them associated with the stores. So I mean, everything is happening under the hood, but the idea is that you supply for each data store, you would supply the list of examples of the questions which should be routed to this one. And once the query comes from the user, you embed it as well, and then search through these examples and try to find which ones are really matching. So
okay, but this is already sophisticated. This is already more convenient what you did. Do you have already annotations for it, or is support, or
no annotation? But there is a class which does basically this. So you on the input you provide the enum and a list of text, a list of queries for example queries for each enum value, and then you provide the text. So once you provided the examples, you constructed this object. It's called the embedding model text classifier. And then once you have it, you just provide the string as an input, and you get back the list of enums. And you then having enum, you could just then do if, else, switch, whatever, and route it route it programmatically to whatever store.
So you are more sophisticated. What I wanted to do is, because I didn't knew that there is a built-in support. What I will do is, okay, look, this is my data source. This is an URI, let's say, because I would try to encapsulate it as a REST resource or whatever. And how to create the metadata is, okay, I can describe it by myself a little bit. But then, as you said, I will provide the questions. but then also the answers from the model as an example, then create from the text, an embedding and use this as a classifier. This is what I will do by hand. That you have, examples, question, answer, question, answer, question, answer. Then I have the embedding, and then we'll find, the resource. So this was the idea.
Yeah, can work as well.
Mm-hmm.
Yeah.
And you do it automatically, so it's even better. But I thought, no, if I would just use nothing, so you're in memory embedding store, and I will have, to do the rec, what we discussed right now with multiple data sources with my first idea. But you did it even better. So you have the enum, and you're done.
Yeah, and you can apply this idea not only to rec, but also to a selection of to route the query to different AI services. So again, coming back to that idea, to instead of having one big AI service which will handle a lot of different cases, it will have a very complicated system prompt with all the instructions about, in this case do this, in that case do that, and so on. You could decompose it into multiple smaller, more specific sub-steps or sub modules, AI services, specific ones, and then you could use this classifier to route the user query to one or another. So if in this example user complains, you route it to AI service which is
Definitely.
which has the system prompt like you should be very polite, you should ask questions about, collect all the required information detailed about the problem, and so on and so forth. And it might have access to specific tools which will be needed in this specific use case. So for example, a tool to open a ticket automatically in some system, or I don't know, something else. But the idea is that in this case you could also, if the service has lots of tools, you could also, instead of providing the model all the tools on each call, this will be very expensive. You could also use this classifier to find the right tools for the job. So when the query comes, before sending the query and the tools and all that stuff, you first classify the intent, find the right tools, and only then inject it into the prompt, into the request to the model, and send it.
So you actually could use the proper injection in Quarkus with this. You could actually create proper qualifier with different data sources, and on the other side you can create producers which producing depending on your enum, the right stuff. So it will be really a micro profile application, fully integrated. So I just inject one thing, and depending on the question, I get different resolutions back.
Yeah, that would be really cool.
Yeah, this is simple. So this is just micro profile. This works for years. But what you are saying is this is the interesting part, right? So the power is integrating Langchain with the power of CDI and Quarkus. So this is actually the killer feature here. So yeah.
Yeah, I think Quarkus team is working, doing a great job at integrating Langchain4j into Quarkus. So I'm sure.
Yeah, for the starters, for the listeners, I think if you just add the Langchain4j OpenAI dependency, one single dependency, and I think with one, it needs one additional class with some annotations, and then JAX-ORS add to it, and you are ready to go. So this is all you have to do. So this is incredible.
Yeah, that's awesome.
Perfect. We are almost over the time, or we are over the time. So next time we'll maybe expand it on your new findings. But where people can find you on the internet regarding Langchain and whatever you would like to know to have. So share information, links to your company, GitHub, or whatever you have.
Yeah, GitHub account Langchain4j. There are also related repositories to that. Also, there is a link to my LinkedIn profile if you want to contact me directly. And also on Twitter, there is Langchain4j Twitter handle, so you could also write directly or tag.
Cool. Yeah. Thank you a lot.
Yeah, thanks a lot. You too.